This is the second part of the homework number 1 hint. Today we're going to have trying to achieve a few things. First is how to dealing with assembly. Second is how to dealing with the different processing time in the inspection, also in the assembly, how to cross-route the parts between the assembly. So before we do that, and also we want to do is for a backup station to simulate the queue overflow situation. To do this, let me just give a quick rundown. Here we have assembly 1, assembly 2, just using a combiner which combines the electronics and the screen together. This is fine for just straightforward implementation, but in order to do the cross route, I cannot reroute the parts coming out of combiner to here because they already combined. They don't know which one to go with. So what I need to do is first I'm going to set the processing time for the combiner equals to 0. So this is just a dummy combiner for the logic. Don't take any time. I'm going to change the name of these combiner to combine 1 and combine 2. And also I'm going to adding 2 workstation, actually called assembly 1 and assembly 2. Okay, assembly 2 right here. This one we're going to call it assembly 1, and this one I'm going to call it assembly 2. Okay, and then I'm just going to link the combiner straight to here, link the combiner 2 strictly to assembly 2. Alright, and then there will be a path going from assembly 1 to post inspection as before, and there's one path going to assembly 2 to post inspection. Also, and there should be a path going from assembly 1 if they are model B supposed to go to assembly 2, and there is supposed to be another path goes through from assembly 2 to assembly 1 if they are model A. So actually what we're trying to say for model A, it comes down this way, go to assembly 2, then goes to assembly 1. So therefore I can make a decision, for example on the link way portion, I can say entity is TVA, TVB actually. If it's TVB, supposedly meaning I'm done. So if it's assembly TV1, meaning assembly 2, it has to go to assembly 1. So I'm just going to do this. Entity is TVA. A copy of these. I'm going to say so it's TVA going this direction, TVB actually is done. We know that is already coming from assembly 1, so it is done. And also I'm going to change this transfer no using shortest path to by link way. So it's TVB actually going this direction, TVA going that direction. Same thing, we're going to do it for assembly 1. So for assembly 1, if it's TVA, it's supposed to meaning it came from assembly 2, now done with assembly 1, it should go to post inspection. However, if it's a TVB, actually should go to assembly 2 in that case. So I'm going to do that. So that pretty much solved my problem. Okay, this pretty much solved my problem with the processing routing between 2 different part type and cross routing. Now I'm trying to address the processing time over here. Processing time over here actually I I should go with the data table real quick. So the data table I have set up, I call this table assembly processing time, assembly PT table. So you should see that on the right. The name is, this is supposed to be processing time for assembly stations. I want you to pay attention to how I set it up. Okay, I set it up 2 columns. One we call it assembly 1, one we call it assembly 2, and actually each one of them has its own distribution. I mean, in here is actually the same, but you could have a different distribution right here. So assembly 1 is a real number expression property, and default value is supposed to be time, and it's supposed to be based on minutes. Also, the second one is also using time units and with minute as its basis. So it's kind of important because we're going to call this table to generate the processing time for assembly, 2 assembly station. So the first row means assembly 1, model A, assembly 2, assembly 1, model B, assembly 2, model A, assembly 2, model B. So how I'm going to referring these actually, I'm going to show you actually what I need to do. I can directly reference this table in assembly 1, for example. The processing time actually should be, I'm going to using assembly processing time, actually using, I'm going to use first column, model entity, model type. Okay, and 1. So I'm directly using this data table as a index table. You can see that the first determine is a model entity type. I'm using the first column. So for rows, it depends on which model type. So therefore, I'm coming back just to explain again. For assembly 1, I'm using first column, and depends on the model type as a different row. So that's how I'm going to access this. Okay, and I'm going to do the same thing for assembly 2. I'm using the second columns right here. So that concludes how I'm going to be able to use the processing time for assembly. Now I can see how many lined up here, how many queue actually lined up this way. So you see the assembly 1, assembly 2, there are mixture of model A and model B because they are cross routing, and also they're coming through this post inspection process. And we can do the same for the post inspection. We can do the same for the inspection. I'm not going to repeat this thing. I'm just going to show you how to do that. Actually, for the inspection station, it is similar. What we can do is we can establish a pre-inspection table. We call it pre-inspection table, and depends on the part type. Is it screen or electronics? And this is model A and model B. And the way we're going to reference this is going back to the facility. All we have to do is changing the processing time right here, referring to the pre-inspection table. And first I'm going to use model entity, model type, okay, and model entity. Supposed to be part type. Part type means it's a screen or a electronics. So we do the same, and I trust you can set up a data table like this yourself in a two-dimensional, one-dimensional sense, and something similar to things we set it up for the value array. You can directly use that for setting up post inspections and so on and so forth. Then to summarize this real quick, I set the combiner, just a dummy combiner in terms of logic, just bring the two parts together and then send it to a real assembly station for process, and therefore the processing times go on this, and I show you the cross routing of between the assembly station and forward to the. And the next things we're going to talk about is assembly 2. So I'm going to zoom into assembly 2. The assembly 2 have two different type of has another special situation is their buffer space only have 10 buffer space, and usually what we can do is you can set the input buffer to 10. However, if you set this to 10, it's not going to reroute the parts going through. It's not going to reroute the parts going through the backup. Instead, it will block everything in the output buffer for the combiner. So I'm going to show you this effect, and you probably see that. I'm going to show you this thing. When you have more, it's just going to block everything in here. It's going to see, you can see that it will start blocking the stuff over here and not allowing it to come in. So this is what we do is probably not a good idea. And so what we need to do is actually putting a, still set this to infinity. Okay, instead I'm going to tell the thing is, first I'm going to grab a backup server, and we'll call this guy backup. And what we need to do is we link the backup server as a detour for assembly 2. You'll notice that what I did is I'm just taking parts from the input node for the assembly 2, and I'm sending the parts that process back to the output node of assembly 2 so they can follow exactly the original routing logic. So it's not messing up any of the logic. So, and I believe the processing time for this is uniform. So let's set this up. It's uniform distribution between 20 to 25 minutes. All right. So, however, how I'm going to let the part go into the backup, and here I'm trying to do is there's an advanced option. I'm going to show this a little bit more. Call transfer in constraint. Instead of using default, which is if the queue is full, is not going to let anybody come in, I'm going to say customer condition. So, and I also say, okay, assembly 2 station is input buffer, number of waiting, I think it is content. Number of waiting. So in the input buffer, number of waiting right here is greater than less than 10. I allow them to come in. Is greater than or equals to 10. I'm going to reroute to the backup, and therefore the backup will have some portion going over. Let's see if this is happening. Okay, you can see that I'm just going to run it real fast, and you can see that their backup actually going over. And I can also show you a couple of things. It's easy to recognize, and I'm going to show how many parts are actually waiting in the part. So I'm highlighting assembly 2. I'm going to put it right here. I'm going to change the color. Purple, for example, actually is input buffer and content and number waiting. Okay, same thing. I'm going to do this over here, making a label, and I can change that to pink, for example. I'm going to do input buffer content number waiting. Alright, so I'm going to let this run. You can see that exactly how many. When it reached more than 10, it will start queuing up on the backup assembly, and backup assembly process it and just send it back to here. So still follow the original. So this pretty much concludes the second section of the hint. So I want you to pay attention. We did the cross routing using the data table to put into different processing time and so on and so forth. Thank you very much.